Jai Hind all. Today I am going to start with the subject electric drive, and the code is KEE075. I am taking the topic from unit 1 of subject electric drive, that is introduction and block diagram representation of electric drives. So first you understand, before start with the subject, you have an idea about the electrical machines and the power electronics converters, right? Because it's a final year subject, so machine and the power converters are the prerequisite that you have studied in the previous semesters, right? So electric drive, actually drive is the meaning of the rotation to provide the motion to the load. So these are the my content. Like, uh, first we see the electric drive, the features of the electric drive, the block diagram, then the power modulator, sources, control unit. These are the electric drive components, that is power modulator, source, and control unit. Then why we choose for the electric drive, and the classification of electric drive. So electric drive, like I said, the motion control is required is large number of industrial and domestic application, like in the transportation system, rolling mills, paper mills, textile mills, machine tools, fans, pumps, robots, washing machines, etc. So where we require the motion control, then we use the electric drive system to get the to fulfill the load requirement, right? Like system employed for motion control are called the drive system, and drive system, it can be mechanical or it can be electrical drive system. So in the electrical drive system, you have more features than the mechanical drive system. So like system employ for motion control are called drives, and they may employ any prime movers such as diesel, petrol engine, gas, steam turbines, steam engine, hydraulic motors, electric motors for supplying mechanical energy for motion control. So where we use the electric motors, it can be considered as a electric drive. So these are the features. With the help of electric drives, it's you can say it's a closed loop system. So they are flexible control characteristic. We reach to the requirement of the load, because if we characterize the load can be expressed in terms of speed and torque characteristic. If you express the mechanical load, it can be expressed as a speed torque characteristic. To fulfill the speed torque characteristic of the motor requirement, we use the electric drive system to get the and we also, with this system, we also control the flow of power, so that we also save the energy of the whole system. So they are flexible control characteristic. The steady state and the dynamic characteristic of the electric drive can be shaped to satisfy the load requirement, and with the help of the system we can also increase the range of the speed, range of the torque, and also the power. And with the help of this, as we save the energy, and this we control the flow of power, so it gives the higher efficiency, and reduce the losses, so the efficiency will be higher, and the no load losses, and considerably short time overloading capacity. And also one of the main feature of the electric drive, it can be one drive system can be operate in all four quadrant, right, in the speed torque characteristic plane. Like it can be the same arrangement, the same blocking system, block system can be used for the motoring operation, for the braking operation, for the forward motoring, forward braking, reverse motoring, and the reverse braking operation. So these are the some of the features by which that's why the electric drive system is more uh, demanding in the industry nowadays. These are the part of the electric drive system. As we have seen that this is the source, the power modulator, motor, load, sensing unit, and the control unit. As you see, this is the closed loop system. The main part of the system is the power modulator. source, it could be a anything, it could be a AC source, a DC source, depending upon the availability of the source. Then power modulator, and this is the motor, and this is the load. So to drive this load, these arrangement has been arranged to get the to fulfill the load requirement, so that we can run the load efficiently with the higher efficiency and lower losses, right? So source could be anything, it can be a single phase or it can be a three phase, it can be a single phase, it can be a single phase or three phase. Power modulator, this is the this control the flow of power from source to the motor so that the load requirement can be fulfilled, right? And power modulator is the it's actually the converter. It can be a AC to AC converter, it can be a AC to DC converter, it can be a DC to DC converter, depending upon the availability of the source and the motor requirement. Motor, like suppose the motor is AC, so you need a AC input to the motor. So power modulator should be such that so it provide the AC voltage depending upon the load requirement, and if it has to be provide the AC motor. So the power modulator in such a way, so it can be a DC to AC converter or AC to AC converter depending upon the availability of the source. If the source is DC and motor is AC, you must need the DC to AC converter, and if the source is AC and the motor available is AC, so you must need a AC to AC converter. And how this work, when the load, suppose you are running a load at a constant speed or some speed, so it is sensed by the sensing unit, and it generate the control signal by taking the reference as this, and this is the real time data. So you are getting the control unit depending the difference between the reference value and the current value. So you'll get the control signal and it will feed to the power modulator. So it suppose it's a thyristor based converter, so firing angle is, you can say it's by using the control unit we can decide the what is the firing angle of the power converter. According to that, the flow of power can be controlled, right? So this is the parts of electric drive. The main, even all the blocks are important for the drive system importance, but this power modulator is it's the heart of this drive system. And also depending upon the load requirement, you can choose the motor can be AC motor or DC motor or the special kind of motors, depending upon the, nowadays the motor is like special kinds, because nowadays the load are the because in this industry the many types of load characteristic will be many types of loads are there, so they have their own speed torque characteristic. To drive that complicated kind of speed torque characteristic, we must choose the motor, or we must choose the power modulator, so the requirement of the load can be fulfilled, right? So motor could be a DC motor, the AC motor, or special kind of motor like BLDC motor, brushless DC motor, or the switch reluctance motor, or the permanent magnet synchronous motor, or the stepper, because stepper motor is now it's a small it can be used for the small rating. And source kit could be a single phase or three phase, or it could be a DC voltage. If it is a DC motor, so power modulator must be DC to DC or the AC to DC, or it can be a DC to DC converter, or it can be a rectifier. So, and the like if you take the example of electric vehicle. So electric vehicle have the it's a load, you run the electric vehicle, so you need nowadays the BLDC is more demanding motor for particular AC motor, a particular electric vehicle load. So for that we need a BLDC, the brushless DC motor. So it's need a DC supply, but internally, because it has the electronically communicated device motor. So in the one package you have the converter AC to, or you can say inverter DC to AC voltage, and the motor is connected, and there is a sensor inside this. So this is how the your drive system will work. So this is part of drive system. Now we'll discuss, because as I said, this the power modulator is the heart of this electric drive system. So it's very important because its main function is to convert the uh, source voltage to the required voltage, power. If suppose if your motor is a AC motor and the available source is the DC source, so you must need to convert DC to AC. So the power modulator must be the converter, AC to AC converter. So so these are the, so power modulator, as I said, the power modulator has some function. It's a main it's a very important part of this electric drive system. So they have some functions, like it modulates flow of power from source to the motor, so in such a manner so that the we get the required, we fulfill the demand of the motor, actually demand of the load, because every load, uh, like industrial load or the residential load, the commercial load, can be described by the speed torque characteristic, and this, to achieve this speed torque characteristic, uh, by the because motors are limited, and this the loads are, I mean, you can say it's very large number. So to meet the requirement of the load with the help of a limited number of motor, we need a power modulator uh, that will help to get the load requirement with the help of the motor, right? Second, so power modulator has the very important function. So it control the flow of power so that you can meet the load requirement. So with, as we control the flow of power, the losses will be less, and it will the efficiency also will get increased, right? So second function of the power modulator, like in the transient operation, like starting, braking, or speed reversal, it restrict the current within a permissible limit, like because at starting the current will be very high, so it restrict the main function of the power modulator. Also it restrict the uh, starting current, right? Because if we, the starting current is increased, because the loads are connected in parallel, right? So if the starting current is increased, the dip in the voltage will be there. So it also manage this kind of things also, transient operation also. And also it convert the electrical energy of the source in the form of suitable to the motor, as I said earlier, like depending upon the availability of the source and depending upon the motor, which kind of motor you are using to drive the particular load. Like suppose electric drive, I just take an example of electric drive. So electric drive generally drive with the help of BLDC motor, the brushless DC motor. So brushless DC motor input voltage is required a DC voltage. So power modulator must be a DC to DC converter or AC to DC converter, because the motor, the BLDC motor needs a DC voltage in the because it's a BLDC motor itself, it's has a inherent converter which convert the DC to AC, because that indirectly BLDC require the AC voltage, and which come from the DC to AC converter, that is inverter, and this DC voltage come from the power modulator. So with the help of DC to AC converter or the using the inverter, we can drive the BLDC motor, and that can able to drive the electric vehicles. So a special kind of load, you can say. So so depending upon the load requirement, or depending on the availability of the source voltage, we can choose the power modulator. Either it is AC to AC, DC to AC, DC to DC. Different kinds of modulators are present, and we can choose. Uh, and third, with the help of one block diagram, one electric drive system, we can perform 4 quadrant operation. Like we can perform the motoring operation, forward motoring operation, we can perform the uh, forward braking operation, reverse braking operation, reverse motoring operation. So with the help of this power modulator, we can now able to do this kind of operation in a one, with the help of one uh, arrangement, one electric drive system, right? Like in electric vehicle, the regenerative braking are nowadays used. So in the with the help of regenerative braking, we can store the energy. It is feeding back, the load side energy is feeding back to the source side. So if it is the battery is connected, so we can save the energy from in the battery, or we can utilize that energy, right? So this can be happen with the help of power modulator, right? So now in power modulator, there are the main part of this power modulator are converter, as I said. Second is the variable impedance switching circuits, right? So in the power in the converters, so need of converter arises when the nature of available power is different than the required by the motor, right? Like if you see this this block diagram, you can see the source and the motor. So depending upon the available of motor, depending upon the availability of source, we can choose the power model, we can choose the converter, which kind of converter we are using. So either it can be fixed voltage and fixed frequency, fixed voltage DC, or controlled voltage DC, or controlled AC voltage required. So there are 4 types of converters: AC to DC converter, AC to AC converter, DC to AC converter, or DC to DC converter. So first is a AC to DC converter. So this AC to DC converter, where if the available power is AC and the motor requirement is DC. So suppose it is a DC motor, or it can be a BLDC, special kind of some motor, BLDC motor. So we need a AC to DC converter. Right, so it's a AC to DC converter is the, so AC to DC converter, it's a fixed voltage. Uh, mm, like first, if you see the first A diagram, so if you see the fixed voltage single phase and the 3-phase, so diode rectifier can be used to convert the fixed voltage to the fixed voltage AC to the fixed voltage DC. So it can be a single phase diode rectifier, or it can be a 3-phase diode rectifier. If we see the B block diagram, so in this fully controlled thyristor, it is the first is the diode based rectifier. We cannot control the flow of power, we cannot control the voltage, only the fixed voltage we are getting here. But in fully controlled rectifier, which is a thyristor based rectifier, so we can change with the help of changing the firing angle, we can change the input voltage, and we get the variable output voltage DC magnitude. We can change the magnitude also, right? So fully controlled thyristor rectifier can be a single phase or a 3-phase. With the help of single phase, we can change the single phase to the DC supply, and we can change the 3-phase AC to the DC supply. Then fixed voltage single or 3-phase. Then the D is the, with the help of transformer tapping, creating the isolation between the, so fixed AC first converted into the variable AC with the help of transformer, then variable AC can be converted into the variable DC voltage, right? So in a similar way, you can see that a lot of configuration can be used to convert AC voltage to the DC voltage, right? Now AC voltage can be controlled, AC fixed AC voltage can be converted into the variable AC voltage. So with the help of AC voltage controller, it can be possible by changing the fixed available single phase or 3-phase voltage can be converted into the 3-phase fixed variable AC voltage, right? So first is it is a transformer based, like auto transformer, fixed turn ratio. So with the help of auto transformer, we can get the variable fixed voltage. So with the help of tap changing transformer, we can get the variable voltage AC supply. And the thyristor voltage control was also there, which is based on the switching device like thyristor based switching converter, that can be controlled, that can be convert the fixed voltage AC voltage to the variable AC voltage, right? So, and the third is the first I have seen the AC to DC, then AC to AC, then this is the chopper, you can say DC to DC converter. Now it is, nowadays it is called as a buck boost and buck boost converters, right? Because it is based on the it is made up of a semiconductor device like BJTs, MOSFET, and the IGBTs, right? So in this fixed voltage, DC voltage can be converted into the variable DC voltage, and so these converters are able to control the flow of power, and which can be achieved by the motor to drive the load effectively or efficiently. So this is the inverter, or the last converter is the inverter. The inverter is actually the converter which convert the DC supplied fixed DC to the variable AC, right? So variable AC can be it's a variable voltage or variable frequency can be achieved, or variable voltage or fixed voltage, variable frequency or fixed voltage can be achieved, or fixed voltage and variable frequency can be achieved, right? So with the help of semiconductor device, this can be possible. So different techniques can be used to control the different modulation technique can be used to control the or to control the fixed voltage to the variable voltage. So we can change the magnitude of the voltage and also the frequency of the voltage. If you are changing the frequency of the voltage, it is called a cycloconverter, right? So cycloconverter, with the help of cycloconverter, we can able to convert fixed frequency and fixed voltage into the variable frequency and variable voltage. So it is also made up of a thyristor based converters, thyristor based converters, right? Next, the part is like in this you can see the power modulator and the source. So source is also the important part of the system. So in like, as you know, in India the single phase and three phase are the 50 hertz supply, so are available in the in India. Also in India the single phase and three phase 50 hertz AC supplies are available. So if the drive system are low power drive system, so where we can use the single phase. If it is a higher power, we have to drive the load which have it require the higher power or higher torque, we need a three phase AC supply, right? So but in traction generally the single phase is used because of economy purpose, like to reduce the cost. In the traction drive system, single phase can be used. So most of the drive are powered by AC source because generally the AC is available, easily available. If you need a DC, you must convert the AC to DC, then you will get DC supply, right? The third is part is the control unit. So control of power modulator are provided in the control unit. Nature of the control unit for particular drive depend upon the type of power modulator employed in that particular drive. Like if you see the as I take example, like when semiconductor converters are used, the control unit could be a firing circuit. Like suppose it's AC to DC converter is suppose, or the inverter DC to AC inverter is made up of a thyristor device. So by changing the firing angle, you can control the flow of power. So control signal, when the control signal is generated, and it can be control signal is generated after comparing the reference to signal to the real time value. So after comparing, the control units generate the control signal, and that can be control the firing angle of the power modulator or the converter. So that will now control the flow of power from the source to the motor. Now we'll see so depend how to choose the electric drive system when you have this kind of this kind of arrangement. So for steady state operation requirement, so the requirement of the electric drive system is you must know about the speed torque characteristic of the load, speed regulation, the speed range, because the electric drive is give the benefit to increase the range of the speed, and it provide the 4 quadrant operation. With the single unit you can perform the motoring operation as well as the braking operation, right? So you must these are the requirement that must be fulfilled to make the electric drive system efficiently, right? So the speed regulation, the speed range, the efficiency, the duty cycle, quadrant operation, as I said, the speed fluctuation, etc. In the transient operation requirement, you must acceleration, deacceleration, starting, braking, and the reversing performance. So the requirement related to the source, type of source and its capacity, voltage magnitude, voltage fluctuations, power factor and harmonics and their effect on the other load. So ability to accept the regenerated power. So these are the some of the requirements that must be fulfilled to make a drive system so that it can run the load according to the demand, so the motor can be fulfill the requirement of the load. And the next is also like other than these points, the capital and running costs, maintenance needs, and the life of the drive system, the space and weight restrictions, the environment and location where you have to install that drive system. So and because if the motor is like induction motor, it is very rugged, it is very environment friendly motor. So so in that case the life of the motor will increase, right? So that is also depend where you have to install that particular unit, right? And how much the unit is reliable, right? Now come to the classification electric drive system. There is a number of machines and interrelations, means of control, the classification of methods of speed control, mode of operation, and the dynamic and transients. So number of machine and interrelation, like according to that it can be divided into 3 types: individual electric drive, group electric drive, and the multi-motor electric drive. So individual electric drive in which the each motor for each particular load the separate motor is required, right? So in the individual drive system, each machine tool has its own electric motor which drive the machine through a belt or a direct coupling, or it can be a chain. So the system is also called the self-contained drive. So each individual machine is driven by a separate load. The motor also impart motion to various other part of the machine. Like in this case, you can see one motor on for each load, the separate motor is there. Like single spindle draining machine and lathe machine. Lathe machine, the motor rotates the spindle, moves the feed, and also with the help of gears and transmit motion to the lubricant and cooling system. So each motor has its own load. So if suppose there is a 10 units, so 10 motors is required. So it's a more costly thing. Group drive, in this one motor can be able to handle the number of loads. So the drive consists of the single motor which drive one or more line shafts supported on bearing. So line shafts may be fitted with either pulley or belt or some gear. So it is also sometimes called the shaft drive. So these drives are seldom used because of the low efficiency, because one motor is driving the number of loads. So but they are economical because as I said, the individual drive is more costly, because for every load you need one motor, you need each motor, so there's costly. Obviously the group drive, in the group drive number of loads are driven by one motor, so it's obviously economically, but with the lower efficiency. So good drive system use high power motor which drive an overhead shaft called the main shaft. Like in this diagram, you can see number of loads are connected with the one motor only, with the pulley and the. So main shaft may run across the workshop from one end to other end. The main shaft sometimes drive another shaft called the counter shaft. Like in this you can see, this is the one shaft, right? This is the one shaft, and this is a one shaft. So this is and this is the 2 or 3 shaft which is connected with the different unit. So that is called the drive another shaft. So this one shaft is drive the another shaft which is connected with the shaft of the motor. So this is called the counter shaft. So counter shaft drives the group of machines through a belting in the pulley, because this is a one shaft and this is the another shaft. So these shaft indirectly running this shaft of the motor with the help of this pulley or belts, right? So multi-motor drive, in this drive system there are several drives, each of which serves to actuate one of the working part of the drive mechanism, and these applications are found in the complicated metal cutting machine tools, paper making machines, and also the rolling mills, right? So drive of crane can also be considered as a part of, as an example of multi-motor drives, right? So this type of multi-motor incorporate 3 drives. First of vertical movement, or side movement, or it is a forward movement. So each of these drive functions separately, and the operation of the crane coordinates their function. So this, in the multi-drive system, each movement can be drive with the separate motor, right? So that is called a multi-motor drive system. So in this lecture we stop here, and we'll, in the second lecture we'll see the different load dynamics of or the dynamics of the electric drive. Thank you.